This video is going to share about productions of Xylooligosaccharides. So, what is Xylooligosaccharides? Xylooligosaccharides is oligomers of unconventional sugars formed by xylose units. It is non-caloric, non-digestible by humans, and most importantly, it exhibits prebiotic properties. Xylooligosaccharides can stimulate the activity of bifidobacterium in the intestinal tract for exhibiting several physiological changes, including reductions of blood cholesterol, maintenance of gastrointestinal health, increase of mineral absorption, and reducing the risk of colon cancer. Besides, Xylooligosaccharides is a valuable food sweetener or additives which could be incorporated in beverages or fermented dairy products. It can be found in fruits, vegetables, milk, and honey. Xylooligosaccharides is obtained from xylem present in hemicellulose. The simplified process are selections of raw materials, pre-treatment of extractions of xylem, enzymatic hydrolysis, purifications, and separations of Xylooligosaccharides. Typical raw materials for Xylooligosaccharides productions are hardwoods, corn cobs, straws, rice hulls, and bran. Presently, corn cobs are getting more attention in the industry of Xylooligosaccharides. Corn cobs are major byproducts of maize processing industries and are regarded as domestic waste. Therefore, it is low in cost. Besides, it has lignocellulosic nature, which mainly composes cellulose, hemicellulose, and lignin, along with lower contents of proteins and soluble carbohydrates. It is one of the most promising Xylooligosaccharides raw materials, since it is made up of high amounts of hemicellulose, which varies between 35 to 38%, which are higher compared to other lignocellulosic materials. Next, pre-treatment. The native form of lignocellulosic biomass is resistant to enzymatic breakdown. This is because the structure of its principal component, cellulose. This polymer presents different degrees of crystallinity polymorphisms and take part of a complex network constituted of cellulose, hemicellulose, lignin, which cause and important problems of accessibility of different enzymes. Therefore, xylem need to be extracted before carrying out enzymatic hydrolysis. There are several pre-treatment methods: complex physical-chemical, hydrothermal, and chemical pre-treatments such as acid, alkaline, and oxidative pre-treatments. Among these pre-treatment methods, pre-treatment with alkaline will be further discussed as it works best with enzymatic hydrolysis. According to Finance et al., the highest digestibility of hemicelluloses was achieved after alkaline treatment with consecutive enzymatic saccharifications and provided a highest amount of Xylooligosaccharides compared with the acid treatments or alkaline extractions. After extractions, extracted xylem undergo enzymatic hydrolysis to produce Xylooligosaccharides done by xylenases. Of the three major types of xylenases, endoxylenases and exoxylenases are the ones responsible for the productions of Xylooligosaccharides. The hydrolysis of xylem involves three stages. First, endoxylenases clasp beta-1,4 linkage between xylose chains, releasing Xylooligosaccharides. Second, exoxylenases acts on the end of the chain and release xylobiose. Third, the xylobiose form is cleaved to release xylose by beta-xylosidase, which may also release some xylose from the shorter Xylooligosaccharides. Enzymatic hydrolysis allows the use of mild temperatures and pH around neutrality, which reduce the degradation of biomass and side compound formations such as furfural and 5-hydroxymethylfurfural and corrosion problems. Low amount of byproducts helps to reduce costs in downstream reaction sections. The reactor suggested is immobilized enzyme with continuous back-to-back reactor. Enzyme is expensive materials. Immobilization has been extensively used to overcome these cost contributions since it allows enzyme reuse for a long time. In addition, enzyme immobilizations can enhance different enzyme properties such as activity, stability, inhibition, and selectivity. Continuous system can accelerate biotransformations, improve productivities, yields, and minimize waste generations. The final step is purifications and separations of Xylooligosaccharides. When Xylooligosaccharides are converted from xylem, a variety of other compounds appear in the reaction media. such as monosaccharides, exertic acids, furfural from pentose dehydration, soluble inorganic components of the feedstocks, and protein-derived products. To produce food-grade xylooligosaccharides, the glucose has to be refined by removing both monosaccharides and non-saccharides compounds to obtain a concentrate with an xylooligosaccharides content as high as possible. Besides, in order to obtain prebiotic effect, xylooligosaccharides need to be in low degree of polymerizations. The process of converting hemicellulose into xylooligosaccharides produces oligomers with a high dpH. The desired range of degree of polymerizations is 2 to 6. There are several methods have been developed for separations of xylooligosaccharides, such as solvent extractions, chromatographic separation techniques, membrane separations, and adsorption by surface active materials. Currently, the most employed method is membrane separations by nanofiltrations and ultrafiltrations. The ultrafiltration steps was employed to remove high molecular weight components including enzymes, but the nanofiltration steps was employed to concentrate the xylooligosaccharides mixtures and to remove monosaccharides and exertic acids. That's all for this video. Thank you.